Imagine a world where robots not only walk but actually enter real combat arenas to test their limits. Batteries last thousands of years, and supercars come with new technologies. Well, it's precisely this fascinating universe that I'm going to talk about now. And I can tell you right away that China is at the forefront of many of these innovations that seem to have come straight out of a science fiction movie. Let's embark together on this journey through the most impressive technologies being developed around the world. And I promise that each discovery will leave you as excited as I get when I see these novelties. When we think of robots, we usually imagine machines performing repetitive tasks in factories or helping with household chores, but reality is transforming rapidly. The Chinese company Unitree decided to take humanoid robots into an environment completely different from controlled laboratories. A combat arena where they will fight each other, fall, recover, and test all their physical limits. I'm not talking about small remotely controlled robots, but advanced machines capable of executing complex movements and responding to an opponent's behavior in fractions of a second, which represents a giant leap in global robotics. The great challenge was never to make a robot walk in a straight line, but rather to keep it standing when unpredictable forces hit its body, as happens during a fight. Each blow instantly alters the machine's center of gravity, forcing its systems to recalculate posture, balance, and movement in milliseconds. And that's exactly why this arena can be considered one of the most extreme tests ever created for these machines. To stay on their feet, the robots combine high torque density actuators with sensors that track the opponent's movements, while dynamic balance algorithms perform continuous corrections on the legs and feet, calculating distance, trajectory, and speed to decide when to attack, block, or retreat. Each impact tests the resistance of joints and electronic components, but the most important result comes afterward. Every fall and successful recovery generates valuable data to improve new control and movement models, turning the ring into a high-intensity laboratory that reveals flaws that would hardly appear in controlled environments. Now, changing the subject completely, let's talk about one of the most surprising inventions I've ever seen: a battery capable of producing electricity for thousands of years. Chinese scientists have developed a new generation of miniaturized nuclear battery based on carbon-14, a radioactive isotope with a half-life of approximately 5,730 years, which means this device could power sensors in inaccessible regions, space equipment, or even medical implants for periods far exceeding human life itself. Although nuclear batteries are not a recent invention, the great breakthrough lies in the compact architecture that abandons traditional heat conversion and directly captures the energy released by the radioactive material, using a silicon carbide transducer that works similarly to a solar cell. The secret of this technology lies in a three-dimensional stacking that reduced the required volume by 17% and increased maximum power by 2.6 times, significantly decreasing the amount of radioactive material compared to the previous generation. It's important to understand that there is a fundamental difference between duration and power, as the current prototype produces only 1.13 microwatts, insufficient energy to charge a smartphone, but its true advantage lies in providing small amounts of electricity continuously over extraordinarily long periods. This characteristic opens up applications in remote environmental sensors, space devices, and electronic systems that need to function for decades without maintenance, such as a brain chip, and in the future, more efficient versions could expand its use in very low-power medical equipment. Meanwhile, in Canada, a completely different race is underway in search of so-called natural hydrogen or white gold, a gas formed by geological processes and stored in underground structures. For decades, the industry tried to manufacture clean hydrogen using enormous amounts of electricity, but now a Canadian startup has begun a new drilling phase with a revolutionary idea. What if, instead of producing this fuel, we could simply extract it from underground? The company intends to test new wells to transform a promising geological discovery into a continuous production system, using seismic data that reconstructed a structural closure area of approximately 14 square kilometers, guiding drilling toward a region where the gas may have accumulated in higher concentration. Previous tests have already recorded hydrogen content of up to 28.6%, in addition to the presence of helium, which is a strategic resource used in medicine, the semiconductor industry, and various advanced technologies. If the results confirm commercial potential, Canada could open a new source of clean energy, allowing humanity to exploit reservoirs produced by the Earth's own geological processes instead of spending enormous amounts of energy to manufacture the fuel. The so-called white gold still needs to prove its scale, but the race to find it has definitely already begun, and the coming years will be crucial to determine whether this will be a viable alternative for our energy matrix. One of the most intimate and delicate tasks in caring for the elderly and people with reduced mobility is about to be transformed by robotics, and China once again is at the forefront of this revolution. Instead of forcing a patient to walk to a bathroom during the night or constantly relying on help from a human caregiver, a Chinese company has developed a robotic toilet capable of going directly to the bed, performing the entire hygiene process, and then returning on its own to a station where it cleans itself automatically. Presented at an elderly care fair in Shanghai, the device transformed the traditionally fixed toilet into a mobile on-demand structure, solving problems that go far beyond comfort. To function inside bedrooms, the system had to solve a rather obvious problem: waste, and for this, it uses a layer of foam that helps contain odors immediately while internal activated carbon filters treat the air. After use, the integrated module performs washing and drying of the user, reducing the need for human assistance in one of the most sensitive stages of daily care, and then the robot uses navigation sensors to automatically return to its station. There, the stored contents are disposed of in the sanitary system, and the reservoir goes through an automated cleaning and disinfection cycle, preparing the machine for the next use, representing an important change in the role of domestic robots in a rapidly aging society facing a shortage of human caregivers. And speaking of robots, how about machines that abandon wheels, mechanical legs, and noisy propellers to simply float around our house like tiny living creatures? Researchers in Japan, together with the United States, are exploring a new class of soft robots sustained by helium, capable of sharing the same space as humans without the dangers normally associated with flying machines. Inspired by characters like Tinker Bell and a certain Pokemon, these devices can approach, gently touch a person, and even envelop them in a kind of hug, all because the gas keeps the robot in the air while small propulsion systems only need to control its direction. The great challenge lies in weight, as 1 liter of helium can sustain approximately 1 gram, forcing engineers to use extremely lightweight structures, microservos, compact batteries, and carbon fiber reinforced components. The most interesting concept is so-called compliance safety, where instead of relying only on sensors to avoid collisions, the robot's own soft, inflatable body absorbs impacts, allowing intentional physical interactions such as gently touching a person's shoulder to get their attention or accompanying users around the house while crossing stairs and obstacles inaccessible to wheeled robots. Still in the world of flying robots, scientists at MIT and EPFL have developed a small robot capable of flying, diving into water, swimming, and then taking off again using the same set of wings. Weighing about 250 grams, the machine attempts to solve one of robotics' most difficult challenges: building a single propulsion system capable of operating in 2 completely different environments, since water is approximately 800 times denser than air. A wing efficient for flying can suffer enormous forces when submerged, while a structure designed for swimming is usually too heavy to take flight. So the researchers developed flexible wings capable of passively adapting to these environments. When in the air, the wings beat at high frequency to generate lift, but underwater, the liquid's own resistance causes them to deform, reducing drag and load on the motors. The robot was also designed with near-neutral buoyancy, avoiding constantly spending energy to rise or sink, but the biggest challenge occurs at the boundary between these 2 worlds. To exit the water, the robot needs to tilt its body at the correct angle and execute a rapid sequence of wing beats capable of breaking the surface tension, managing to leave the aquatic environment and return to flight in less than 1 second, paving the way for low-cost drones capable of monitoring rivers, oceans, and coastal regions. To conclude this incredible technological journey, let's talk about an electric hypercar that seems to defy the laws of physics. British company McMurtry Automotive is taking the concept of aerodynamics to the extreme with a vehicle costing approximately $1.3 million, capable of generating about 2 tons of aerodynamic downforce even when completely stationary. Instead of relying only on large wings and airspeed, it uses powerful fans to literally suck the car against the asphalt, creating a low-pressure zone under the chassis that turns the vehicle's underbody into a kind of giant suction cup. 2 electric fans spinning at up to 23,000 revolutions per minute draw air out of a sealed region under the chassis, and movable skirts help seal this space against the ground, resulting in such intense grip that the car can handle corners and braking at nearly 3G. It is precisely this ability to produce downforce regardless of speed that fuels the idea that under the right conditions the car could generate enough force to support its own weight, even while inverted inside a tunnel. With only 100 units planned for sale, it will hardly be a common car on the streets, but its technology shows something extraordinary. When aerodynamics ceases to depend only on the wind, even gravity begins to seem negotiable. If you enjoy this video, give it a like, share, and subscribe to this channel.